job.
My initial reaction in a situation like that is just, it's anger. It's not again, it's how can this happen, it's what happened, why.
The morning after the crash, NTSB investigators join local and federal police agents at the site. They know the pilots of Flight 592 reported smoke in the cabin. Now they need to find out what caused it.
All right, let's get to work.
The team is led by veteran investigator Greg Feith.
You got to step back, take a deep breath, and then start to prioritize. Okay, what do I have to do now? And then utilize the resources to make that happen. It's showtime. Here we go.
I'll let Greg answer that, but there's actually no way to tell if the pilots were conscious or unconscious at the time of impact.
My first thought is, how am I going to pull this off?
Feith faces intense pressure to come up with answers, and quickly.
I'm determined to do everything I can to make sure that American aviation is the safest in the world.
The NTSB briefs the many volunteers
Attention here.
who've come to help recover the wreckage.
We've drawn up a grid. We're going to scour this swamp quadrant by quadrant.
Everybody's looking to me for the answers because I am in charge of the investigation. What are we going to do? What do you want us to do? Where do you want us to go?
The first priority is to find the aircraft's 2 black boxes.
This is what we're looking for. This here is the data recorder. And this here is the voice recorder. You find one, you'll probably find the other one close by.
From the CVR, investigators hope to hear the last sounds in the cockpit, pilot conversation,
We need to go back to Miami.
and any alarms that might help identify where the smoke originated. The flight data recorder should reveal how a fire might have spread through the sequence of failures it likely caused. Each box holds clues that could help investigators uncover the precise cause of the crash.
If you find one, the cold beer's on me.
The black boxes emit a constant radio signal. Searchers will use a sonar scanner to pick up that signal.
How soon can we get out there with the sonar? Sonar's on its way.
They'll be able to pick up those pingers to hopefully identify where, in fact, those boxes lie in the wreckage.
But Navy technicians soon find that their sophisticated gear is no match for the Everglades.
Side scan sonar didn't work because the sawgrass is so dense it can't see through the sawgrass. What really worked for us was going back to the basics. We had a line of what we called divers that had to walk basically shoulder length apart, and we would cover specific areas, probing till we hit something hard. It ended up being human power that really helped us recover better than 75% of the aircraft.
As the Everglades search continues, investigators in Miami dig through Flight 592's records, looking for clues as to what might have caused a fire. They soon learn that the flight was delayed earlier in the day due to minor electrical problems. The find raises concern that an electrical fire brought down the plane.
We were looking at any explanation. There could have been a fault in the wiring or a short circuit, and we realized it's going to be a very difficult investigation.
Recovery teams continue to battle intense heat.
Florida, in May, 90 degrees, 95% humidity. We had to worry about how long can you be in that heat?
You're trudging through in your waders, and you're stepping on stuff. You have to bend down and you have to pick it up and see what it is.
There were times where, you know, you think you're picking up a wire bundle, and it was a snake. You're picking up the back end of a snake. So it was all of those things that made this probably one of the most challenging environments for an accident investigation to be conducted.
NTSB fire investigator Merritt Berkey studies masses of tangled wiring from the crash site.
I was sent down there to determine the cause of that in-flight fire.
When faulty wiring sparks a fire, electrical arcing causes the wires to burn and melt.
When we recovered more of the electrical harness on the plane, we saw some damage there, but it wasn't evidence of electrical arcing on the wires. It was all external damage to the insulation.
The careful examination rules out faulty wiring as a potential cause of the fire. Another challenge. The Everglades is not a stagnant swamp. It has a current that flows out to sea.
One of the unique things about the Florida Everglades is that it's water, and it's constantly in motion.
That current makes the job of tracking down aircraft debris even harder.
Well, as the water moves, and basically the tide goes up and down, if you will, some of those parts that were trapped underwater in the sawgrass would break loose and float to the surface. You could go back and find more parts than the first day you were in that grid.
2 days into the investigation, Fife finally catches a break.
A hot damn. We found ourselves a box.
It was sitting on the bottom in the mud, partially submerged under about 3 to 4 feet of water.
One of the Metro-Dade Police Fire Rescue folks was walking their grid and actually stepped on one of the orange boxes. The whole accident site, all of the investigators, everybody comes to a halt as soon as the word spreads that we think we got a recorder.
Officials wasted no time bringing it out of the swamp into a police car and onto a plane for Washington.
The aging DC-9 was equipped with a primitive FDR. It recorded only 11 flight parameters, compared to the hundreds recorded by modern units. But the next morning, when Fife studies the preliminary results from Washington, he finds a clue that may point to the origin of the fire.
Dive 800 feet and back in 3 seconds. It's impossible.
The FDR recorded a sudden increase in air pressure.
What we found on the flight data recorder that records the parameter of the static pressure was that there was a bump. It spiked briefly and then went back to a nominal value.
Sensors on the fuselage measure outside air pressure. Normally, the pressure decreases with altitude. But as Flight 592 was climbing, the pressure briefly went up, not down. A DC-9 cannot dive and climb that quickly.
Hey.
The numbers don't make sense.
Look at this.
We really didn't know we theorized about a variety of different things.
Could have been an explosion on board.
A shockwave moving outward from inside the aircraft can cause a sudden spike in external pressure.
And of course, you start thinking, an explosion could do that. So do we have a bomb?
With an onboard explosion a real possibility, Merritt Berkey examines the wreckage to see if he can figure out where the fire originated.
So we had a lot of parts coming in that were damaged, almost all limited to the cargo compartment. We had melted structure components that were in the overhead of the cargo compartment, which made up the floor of the passenger compartment. And then we also had some seat tracks for the passengers that were burned and melted. We determined that the fire was very intense up in the upper area of the cargo compartment on the left side.
Berkey makes an unusual discovery.
It's stainless steel. You don't normally see burned stainless steel in in-flight fire.
Planes are made of lightweight material, like aluminium and titanium, not stainless steel. The burned metal raises a question. Just what kind of cargo was on board the plane? Investigator Malcolm Brenner needs to know exactly what type of cargo Valujet Flight 592 was carrying.
The operations group more and more became concerned about the cargo that was loaded on the airplane and what possible significance it could have to the accident.
The cargo documentation lists 3 airplane tires and 5 boxes of empty oxygen canisters.
The operations group found that the manifest, which indicated that there were oxygen canisters, empty oxygen canisters in the cargo signed for by the first officer.
There you go.
When Greg Feith was available, I briefed him.
Okay. Company material, 3 aircraft tires, and 5 boxes of parts.
Malcolm is a pilot. He has an understanding of aviation. He's a smart guy.
It's the contents of the cardboard boxes that confuse me. 144 empty oxygen canisters.
Wait, how many of them?
144.
An oxygen canister is a green bottle, very large bottle, that supplies oxygen to the flight crew and the passengers.
There's no way, Malcolm. You can't fit that many on a plane.
We all took a pause and said, why would you be carrying 144 of these big green oxygen cylinders? Malcolm asked a very innocent question.
What exactly do you think they mean by oxygen canister?
And that's really what triggered the investigators to step back and say, we need to verify exactly what was meant.
At the crash site, the recovery work continues. The debris includes dozens of small metal cylinders, parts not from the DC-9. Investigators now understand what was in the boxes listed on the cargo manifest.
We found out that it was not a canister, but in fact an oxygen generator.
Oxygen generators are small devices installed above the passenger seats of certain airplanes. They're connected to oxygen masks that drop down in the event of cabin depressurization. Pulling down on the mask yanks a lanyard, which slides out a retaining pin. That triggers a chemical reaction that generates breathable oxygen.
The masks are attached to nipples on this oxygen generator. That's the supplemental oxygen that flows through the tube to the mask.
Investigators wonder whether the oxygen generators that were being carried in the cargo hold could have caused the fire.
We had 5 boxes of these, or 144 of them, thrown in a box, carried as cargo. We had to look at, well, if they're carrying these and they're supposedly empty, what danger is there carrying them as cargo?
There's no question. They're clearly listed as empty.
Did they have a potential for creating a fire or a fire situation that could have jeopardized the safety of this aircraft?
As recovery teams continue to pull oxygen generators from the bottom of the Everglades, they find that while some are in fact empty,
This one's never even been triggered.
many others are full.
The oxygen generators that we had found had been damaged. Some were completely flattened, some of them were charred and crushed, some of them still had the material in them, but the case had been dented and damaged.
It's the temperature of the canisters after they've been triggered that concerns investigators.
These things get pretty hot, Greg. Really hot.
They can reach 260 degrees Celsius. That's why in the cabin they're stored behind a heat-resistant shield.
An oxygen generator that is not mounted in its proper position in a heat sink cradle in the passenger service unit is lethal. Because if it's anywhere near a combustible material, you're going to have a fire.
It now seems highly volatile chemicals were improperly shipped aboard Flight 592. Had the pilots known what was actually on board, they likely would not have signed off on the manifest.
There you go.
they and their 105 passengers would still be alive. Four days after the crash of Flight 592, hazardous materials specialist Jim Henderson joins the team.
Initial documentation that we were looking for was the records of where the chemical oxygen